Hello and welcome to Yeyu Lab. Meta has just released Llama 3.3 70B model. Functionally does not follow its previous version Llama 3.2, which is a pack of edge models from 1B to 3B and vision models from 11B to 90B. However, the Llama 3.3 70B model is a single model that only supports text import and output, which looks more like an advanced version of Llama 3.1 model. The team at Meta has achieved these improvements through innovative alignment processes and advanced online reinforcement techniques. The most impressive part is that Llama 3.3 matches the performance of the much larger model Llama 3.1 405B model, and using the same prompt format, you can replace the model in your existing Llama 3.1 application with the Llama 3.3 to achieve the same generation quality but with much lower cost than before. With the advanced optimization and quantization techniques and tools, you can now more easily to run the Llama 3.3 70B model on your own GPU machine. In today's video, we will explore how you can leverage this powerful new model, which is now available through Ollama, to build your multi-agent workflow locally with Crew AI framework. And in that demo application, I will show you how to take use of the reliable tool calling feature of the Llama 3.3 to build practical agents to analyze the tweets content. Let's dive in. The quickest way to try out the Llama 3.3 is to use the Online Inference service by its OpenAI compatible API. If you search for it, you will find there are many services right now with different pricing plans. From the benchmark list of OpenRouter, I will choose Novita AI as the inference API provider because it provides BF16, which is one of the most efficient precision in the list. The others mostly provide floating point 8. And although the throughput is not so high compared to the other providers, but its price is almost the lowest, which is only 39 cents per 1 million tokens for the input and output. So if you move to the Novita AI platform, welcome 50 cents free credit is enough for you to have a first trial without any computing infrastructure setup. So you can go to novita.ai and sign up for an account. After that, you can go to LM Playground, select the Llama 3.3 70B instruct model, and then ask something immediately, which is bigger, 9.11 or 9.9. 9.9 is bigger than 9.11. That's very good. That's very good response. You know, many models cannot make the right answer to this math question. And then you can go to its API section and go to the Python, copy the code to your coding environment, replace the API key to your own, and change the model name and run. You will find the code is designed to generate the response in streaming mode, and the speed performance is not bad. Now, knowing how Llama 3.3 performs, let's build a local agent workflow to analyze the tweet content. Before we start, we should make sure we have local computing resource to run the 70B model. The 24 GB GPU can run the inference as a minimum requirement. But if you want to run it in an acceptable speed, you should use at least 48 GB memory for GPU. If you don't have such GPU in your local machine, we can go back to Novita AI to its GPU instance to rent a cloud GPU environment with an effective price. You can go to the GPU page to create a new instance by selecting the GPU type. Here you have a couple of choices, 4090, 3090, and A100. and 6000. For this demo, I will use two RTX 4090 4GB GPU, which totally have 48 GB memory for only 70 cents per hour cost. And you can start or stop the instance as you need to prevent unnecessary cost when you don't use it. And also after you stop it, you can save the image to the Docker Hub for preserving the environment and data. After your GPU has been deployed, connect your new server with the SSH connecting string, and now you have your own dedicated GPU to run the model inference code. If you are also interested in using the GPU service on Novita AI, please kindly support my channel to use the affiliate link below. Appreciate it. So the first step is that we need to install the Ollama, which is a lightweight tool for running Llama models locally in a very simple and effective way. Depending on your operating system, you can follow the instruction on the Ollama webpage to install it. After the installation, you can start the Ollama server by running Ollama serve in your terminal. Okay, now the server is running, but we don't have the package of this model in my local disk, so we need to pull the manifest of the model from the model center. Use the command Ollama pull Llama3.3 to download the model. It will take some time depending on the network status. Because I have already downloaded, so I will not run the command. So assume the model is downloaded. Now we can move to the coding walkthrough. Now let's build Llama3.3 Crew AI multi-agent app. In this demo, we will create two agents and make them work in a sequence. The first agent will execute a custom function as a tool to scrape the tweet content from a defined user, and the second agent will use that tweet content to generate a structured summary in our defined categories. So first, we should make sure we have installed the Python library, including Crew AI Tools, Ollama, and Tweetkit, which is a very interesting library for scraping the tweets. In the code, let's get our imports. Because we are bringing in the core components of Crew AI, so we import the agent, the crew, the process, the task, and LLM. We also import the base tool because we are creating a custom tool for our agent to use. Then we have the Tweetkit, including the client and tweet, which is the class for us to scrape the X. And we also need to define a .env file to store our authentication for X account. So they're actually your username, email, and password. There's no need for X developers API authentications. Now, first in the code, let's create a custom tool that will allow our first agent to scrape the tweet content. We're defining a class called Twitter Scraper Tool, and it inherits from Crew AI's base tool class following the Pydantic methodology with a name and description section. And the run function takes one argument, which is the username of the user that we want to see the tweet content. Inside the run, we define a function called getLatestTweets. Here we create a Tweetkit client with the authentication we provided and use the getUserTweets to download a list of the tweets from the given user. And here for a simple demo, we only collect one latest tweet. Then let's define our tweet summary model using base model from Pydantic. This class defines the output format of our task, including the product, category, description, and highlights abstracted from the tweet content. So that's what we want from the second agent who can generate the output following this structure. Okay, now that we have the tool, let's create our agent. We are creating two agents here, which is the collector agent and analysis agent. For the first collector agent, We define its role and goal and backstory to ask the agent focusing on collecting the tweet from the web, and give it our designed tool, Twitter script tool, and the LLM, which is where we connect our agent to a language model. Here we connected the LLM to the Llama 3.3 by Ollama, served locally at localhost with a port 11434 that the server already set up by us earlier. So you should also make sure your Ollama server has been set up and the Llama 3.3 model has been downloaded. The analysis agent is similar, but it has a different role and goal. It's a tweet data analysis designed to analyze the tweets from the collector agent. And we also equipped the agent with the Llama 3.3 model that we served locally. Now let's define our tasks. So it's very simple that the first task is to fetch the latest tweet for the user ID that will provide when the workflow begins. And the agent should be collector agent. And the second task has an expected output that is a summary of this tweet's content, which provided by the analysis agent. And here we give output Pydantic as a summary class, which has been defined earlier. Finally, let's create our crew and set it in motion. Here we create a crew instance with the 2 agents and 2 tasks, and the process is sequential, which means the task will be executed one by one in the order defined here. And finally, kick off the crew by providing the user ID that is the account of Meta AI on X. So that's it. We can run it now. Okay, we are all set. Let's run the program. Yeah, after a few seconds, the whole workflow has been completed. It's a quite acceptable speed on the 2 4090 24 gigabytes GPU. So let's see the first agent, Twitter data collector, using the tool Twitter scripter that we defined, and use the input for the user ID. And the final output is the tweet content of the Meta AI. This one, the Twitter that's introducing SPDL, right? And then the second agent, Twitter data analyst, analyze the content and follow our defined format to generate the analysis, including product, SPDL, category, AI model training, description, and highlights, including the key advantage of this product. So that's the entire workflow under Crew AI framework by using the local deployed Llama 3.3 model with Ollama. So you can try running this code by yourself and experiment with different user IDs and see what kind of insights you can generate. That's all for today. For the tutorial and the source code, you can find the link in the description below. Don't forget to like, subscribe, and hit the notification bell. Keep innovating, and I'll catch you in the next one.